Yeah, so good afternoon, and well, thank you for coming to this last talk. I hope you really learned a lot of new things during those 2 days, and you'll find out something useful during this talk as well. My name is Žygimantas Medelis, Sigismund, I guess, in Polish version. I'm working in Lithuania, Vilnius, with a small team on language generation. And again, since it is the last talk, let's probably be less technical and get a little bit more, well, philosophical. And what is data? PyData with Python or just data? Why we use it? How we use data to communicate some kind of a message? And how does that relate to the other mode of communicating messages through the storytelling, like a much older technology than the data science? And that's what I would kind of want to underline, this difference between data-driven messaging and story-driven messaging. The conference started with the keynote yesterday on ethics in AI. And what we see when we talk about AI, it's mainly these big data-driven solutions, which also show some issues like bias, this and that, and there is no need to repeat all the funny or a little bit sad instances of all sorts of bias. No matter how much data you will push into machine vehicle to decide who to hit in the unfortunate instance of a car accident, there is no way for the machine, for the vehicle to kind of have this purely data-driven decision. And when we think about how we as humans do that, we tell the stories to ourselves. What if? All sorts of counterfactuals. What if I will do this? This will happen, this and that. What we do is not really the statistical data-driven decisioning. It's more like this causal inference. And through the language, through narratives, we are building that. That's our kind of internal tool. And data, on the other hand, is kind of profoundly, dumb. There is nothing really causal in it, nothing really, telling me why, explaining me what happened. So with this in mind, when I started like that, I probably should have named my talk like, I don't know, solving global warming and bringing peace to Earth. But so let's go a bit more into more details about how we are applying. Why, again, language is important to explain what's happening. A graph, yes, the data, the language of the data, graphs. And we can look at it, apply a little bit of thinking, and we can work out the details here. We see a timeline, we see countries, with the different lines. We see some aggregation for the world, and we can infer, and if it's not readable on the y-axis, there's a gram-based protein consumption. So basically, people are eating more and more meat per worldwide. But we have to do this mental exercise to arrive at this conclusion. So what I'm saying is that data through charts is immensely, of course, useful tool. It allows us to analyze it in all sorts of slicing and dicing. But it's actually this sentence. When we see it, we are much faster to process it, to process the meaning, and do the action, do the decisions. At the end of the day, it's decision making, which is important, application of data science and building dashboards. So imagine also that the same data goes to Japanese agencies. It's this yellowish line. Yeah, totally different trend. So the sentence to be generated is different, like something like Japan should continue supporting or doing this trend of downward consumption of animal proteins. when we talk about natural language generation, there are those two, let's say, very broad domains or areas. One is conversational interfaces, and yesterday there was also a very good presentation by Amit from Booking.com, how they are applying that in chatbots. It's for the chatbots, of course, not only an LG, but you also have to understand the language. But that's one area, and I'm not touching it. It's different, let's say, different domain. What interests me is data to text. So you have those, in a simplest form, CSV files, and you have to describe them. So where you have data from any sorts of sensors or business environments, and you want to generate descriptions for that. So it's slightly different. It's different from conversational agents in that you have to be really precise in what are you generating. So kind of the textbook example of natural language generation is weather reports. Yeah, so you have weather temperature, wind speed, humidity, and you generate reports saying, don't forget an umbrella. So for that, of course, you don't need the NLG technology. But imagine you are a operator at the Norwegian fjord cruise. And your job is to prepare the crew on the ship and the passengers for that trip. You have to provide data and kind of the description for the captain how to comply with the regulations. Maybe because if the wind speed or wave height is bigger than something, by the regulation that and that, everything has to be tied to the ground. For the customers, you need to generate descriptions, what kind of clothes to take and so on. For the engine operators, how to optimize fuel consumption. So all of a sudden, this complex job of handling weather concerns, business concerns, regulation concerns, turns into the grueling job of writing 100 reports for 20 ports, because there are like many stops along the way for the different stakeholders in that domain. So, and the data is always the same, yes. So you don't want to kind of repeatedly run the same report with different parameters. So even in the domains where apparently there are no such a broad scope for the natural language generation, it looks like, okay, you can have a template or something. Even in those cases, we are quickly seeing that some kind of automation is necessary. Yeah, so where is the gap in all that process? Again, as I was starting, we can replace business intelligence basically with any sort of data analytics, Jupyter notebooks, whatnot. Yes, everywhere where you have to communicate the message based on your data. So there is this gap that you always show, nice charts, nice slides, but there is no call to action, no description of why this or that is important. It's up to the reader to infer that. Again, I don't want to say that natural language generation explains everything there is to know about this business domain. But since we are this kind of a story consumers, seeing some kind of a text, explanatory text, in fact triggers faster our discussions about this, our thinking, again, this causal inference. That's a screenshot from the Metabase business intelligence system, open source tool, which has kind of a nice setup. Again, as in the previous examples I was showing, after examining it a bit, we can understand that it's all about sales. there is some kind of, upwards dynamics in sales, but we don't really, get the message. Do I have to act on that sales data, or should I hold? Do I have to call Bill to clarify something? There is nothing really in here when we look only purely at the dashboard. Just before going forward, I think that's also the same for the other data science domains. The adoption rate, the usage of those tools in business is really low. So companies invest like gazillion of dollars in trying to bring tools which show the data to the business, but then nobody's using them. Why? Part of the reason is that there are different functions expected from the BI tools. So from IT, marketing, to the executive management. So think about this again, this Norwegian ship with a lot of different stakeholders inside who need to consume the same data, but with different emphasis, different messages, different things to do about it. And the same also, different objectives. What do we need from that? So again, the data is profoundly silent for all of those different domains. And text can come to the rescue. There is actually I think there is a point in why all the fairy tales start with this once upon a time. Because that kind of signals for us that we are transitioning to different worlds, that there is some kind of imagination and so on. So again, when I'm adding some kind of text to my descriptions, it sets us on this path of thinking, okay, what do I see here? So if I add to the same dashboard some of the time series analysis, it kind of immediately, I get the message, what's happening. Sales steadily increased from 2017 to 2019, and during 2020 growth still stops. It's a sample data, so that's why it's a bit into the future. But those couple of sentences actually, talk more about important aspects in this data. The same goes for the other dashboards, for the other charts. So yeah, this kind of enriches the ways data talks to us. So how do we do that? Those descriptions. We are building a open source text generation platform, accelerated text, and from a very high level, it's electricity. So from the very high level, it's kind of splits into two modes. From the kind of strategic level, we recognize that we cannot rely on any data-driven approaches. We have to have this more rules-based approach which sets what exactly needs to be told, where it has to be told. And then at the tactical level, think about parts of a sentence, how sentences are joined. Then we can learn from the data how to do that. So it's kind of a mixture of rules and more data-driven things. And for those of you who are following the raging war on Twitter between connectionists and the guys who are defending a little bit of a structured approach to AI, with Gary Marcus and the rest of the deep learning community, that's, I think, the kind of similar thinking that we cannot really have one bullet in language, especially language generation, kind of which solves everything. We have to have this double approach of rules-based kind of strategy, and then at the tactical level, we call it sentence realization, surface realization, the data thing. Of course, for example, there is a lot of scope to even make it more simplified and introduce more data data analysis. For example, I truly believe that ifs, conditional sentences can be eliminated from this abstract meaning representation. We can learn from data which branch to pick based on the input data from the business analysis. So, but still, it still remains as this kind of a programming, very high level programming environment. And for those of you who saw the Lego robots programming thing, it's also kind of exactly the same logic. Right. So there is obviously this elephant in the room here so far, is that okay? It's one thing to generate text, but no language generation system can actually tell you what to generate, what to tell. Yes, so there has to be some kind of a data science component inside. So, for example, if I have a time series, which point in the time series is worth describing? So, what we have here is that, in essence, we're talking about three component systems, where you have some kind of a presentation layer, business intelligence platform, Metabase, Power BI, you name it, whatever you use. Then some kind of a data science tool, which analyzes data and extracts important points. And then the natural language generation system, which starts talking about that. And open source really shines in this area, in this ability to mix and match different technologies. So, and that's one of the motivations why we chose to make accelerated text as the open source project, not closed source. So, but that's kind of a very important thing to always have in mind, because often when we talk about natural language generation, you will get requests saying, okay, so as if the system itself will know what's important to communicate. So this is not the case. You kind of create the document plan with this, but kind of data importance and data points are fed in through the data science platforms. Just to, of course, everyone with an interest in natural language generation talked to transformers. And that's the results you usually get through the deep learning system. So for those of you who didn't talk to transformers, it's trained on the massive amounts of internet text with a huge like language neural nets. And yeah, sometimes it's funny. So it's okay to generate blabbery about fakeish news, but imagine if you want to feed your business data, business reports, something you communicate to the customers through this system. You will get, well, embarrassed at best, and at worst you will get a lawsuit. So that's why when we talk about data to text, we cannot really use purely neural net solutions. That's why in the accelerated text we approach this from this perspective that, okay, the precision is a must. We really have to follow each column in your data and precisely reporting on it. So that's the kind of the key motivation, not to go full speed with the neural net solutions. Yeah, so some of the applications where you can use it. The most obvious one is, and the one we are working now on, is product descriptions for e-commerce. So if you have huge retailers with the hundreds of thousands of items, and you want to have concise descriptions of dresses, of shoes, of you name it, you want to have natural language generation here. Also, what's important with natural language generation, and again, as I was trying to underline in the Norwegian shipping example, is that there are different audiences for reading the text. So when you're describing product for e-commerce, you want to describe it in one way for the teenagers, and in totally different way, well, not totally different, but maybe using different vocabulary for the, I don't know, family man. Yeah, device maintenance reports, that's probably, I will skip to this one, is also interesting because you get something is broken in the engine, yes, and you want to have a list generated, which steps do you want to follow. And from what we talked with people who work at factories, usually it's not the case that there are, professional engineers who are supporting complex machinery. It's usually just, well, not really well-trained supervisors on the floor who really need the descriptions of what and how to operate when something is breaking in the factory. And again, the text cannot really be templated, yes. It changes based on the expertise of the engineer and on the what kind of the breakage we are facing. Right, so once we have this running NLG systems, the benefits are quite huge, because in the environments where a lot of reports or a lot of descriptions have to be generated, we can get this consistent logic, again, which allows me for better searchability, better readability of everything I have. Then again, analysts, data scientists don't have to write repeatedly the same or slightly different reports, which is like distracting them from the real work. What we have had another case is in the banks with anti-money laundering. The anti-money laundering data scientist would have to, after identifying kind of suspicious transactions, would have to write 3 reports, one for the customer, one for the internal bank consumption, and one for the regulator, which is killing productivity, distracting again the specialist from what they are supposed to do, analyzing transactions. So again, having the NLG in the loop really speeds up the whole process of doing business. Right, so that's it. Oh, I'm on time. Almost. Okay, any questions?
Thank you. Any questions?
Thanks very much for the talk. One of the things that I just missed, maybe at the start, but can you just say your organization are deploying and supporting these products? I mean, is this something that is that true? Is it something that's already in production, or is it something that you're working on as a hobby project?
Oh, it's a production. So we have this. You see the GitHub link. So this is the open source product. It still needs kind of a bumping. But yeah, we worked on especially this bank example. So we are deploying the NLG kind of customized solutions, and we try now to make this platform for everyone to have kind of a basic version, so that you can tinker a bit with some knowledge of syntax, how grammars are built, with a bit of a training on the vocabularies. You can start creating and there are more details. The documentation and everything is in that GitHub. So if you are interested, go here and then.
Okay, yeah, and which mainstream, let's say, business intelligence platforms are you currently able to integrate with?
Integration-wise, it's quite simple. So Metabase is just, I picked Metabase because it's an open source and it's in Lisp closure we are using. So I just like it. But then we also employ a lot of Kibana, Elasticsearch. Again, you can push in something. I'd say integration nowadays is it's complex, requires time, but in a way solved problem. Yes. So whatever clients have, it's all let's say doable. And this all works with REST API, so it's exposed here, and it's a question of just plugging it.
Great. Okay. Thank you very much.
Any question? No one?
Well, it's the end of the day, so.
Okay. Thank you. Thank you for a talk.
Thank you.